Number 1, we have this sample of adults living in a large suburb of a large city. We know their ages, we know their annual incomes, and we know there are 207 people initially surveyed. We're supposed to find the probability that a person chosen at random will be in the 31 to 45 age category. So this is just a person at random. This has no limiting condition. It is out of all 207 people in our sample. So of those 207 people, the marginal frequency, since there's just one category, so the marginal frequency of being in this event of 31 to 45 years old would be 89. That fraction does not reduce, but it would be accurate if you've shown the work of where you got it to say that this is about 0.430. However, on part B, I want the probability that someone in this sample will be in that category. But again, it's saying that those in this sample whose incomes are over 50,000. This is another way of saying it's a conditional probability. What is the probability that a person chosen from those in the sample whose incomes are over 50,000? So I can't look at everybody. I can only look at the people whose incomes are over 50,000, which are these people here. So I can only look at those 96. Of those 96 people, we have 35 that are in that age category, because we're finding the probability of being in this category given we know their salary is over 50,000. So if I get the decimal for that, I'm seeing it's around 0.365-ish, which is different than just the standalone probability of being in that age category. Knowing somebody's income was over 50,000 decreased the probability that they're in that age category. If it changes the probability, then you do not have independent events. So I'm just going to say, because the probability of being 31 to 45 is not equal to the probability of 31 to 45 given you know their salary is over 50,000, this means those events are not independent. There are other ways to test that, but since we already had those two values calculated, it's easiest just to use those ways.